Hey there viewers, and welcome back to the South Main Auto Channel. So we've got this 97 Subaru Legacy Outback Wagon here. It's got the 2.5 dual overhead cam engine in it. And the customer had it towed in because it was overheating on him, so he didn't want to drive it any further. Car's high mileage, 250, 280 something on it, a lot of miles. And he's pretty certain it's the end of the road for this little fella. So I brought it in, and, the money light came on, and I guess it started running pretty poorly, obviously, because it was pretty hot. And I checked it out, and it has a code stored in it, which I'm going to show you guys. And it's one that, I don't really know how to word it, but it's one that could get overlooked pretty easy, or it's a type of problem that, a guy may just go through and fix and be like, well, that's it, it's good now, and ship it down the road. But I'm going to kind of show you my process on this as to what I did, so we can make sure that we don't get burned with a comeback, and make sure that it doesn't overheat on this fella again. So I went ahead and pulled the codes out of it, and the only code that's stored in it is this P0483 cooling fan rationally check malfunction. So on these older Subarus, there's not a lot of good service information as far as code setting criteria and what's going on there to give you good direction, other than the fact that obviously has an issue with the cooling fans, and that kind of meets the the symptoms to kind of back up what happened. The customer talked with him when it did overheat. It was not going down the road, it was just sitting there at an idle in gear, and temperature gauge went up, and just pull over, and that's that. So naturally, just pulled up wire diagram. We're going to go through it. We're going to take a look at the cooling fan circuit. I'm going to show you what I found, and then we're going to just kind of take it a step further. So long story short, I took a look at the wiring diagram. Well, naturally first I checked to see if the fans were mechanically seized up, and they weren't. The fans spun. Just kind of visual inspection, see if anybody's been playing with anything. There wasn't any sign of anything. But what I did find, I turned the AC on the vehicle. The AC clutch kicked in, fans didn't turn on. So from there, I just decided, we'll check these fan motors, and we'll see what's going on. And what I found is that this fuse here, in the underhood fuse block, that fuse was blown. And the other thing I found is in the inside fuse block that this fuse was blown. So both of the 20 amp fuses were blown. I don't know if they blew at the same time, if we lost one set of fans and then, eventually the other. So naturally, I replaced those two fuses, checked the fans, and both the fans work. The fans come on, they'll run, and, did not blow the fuse. So I think it's at this point where, the diagnosis can go, one of two ways. Either you can say, yeah, I warmed it up, I kicked the AC on, the fans run. I let the car get hot, the fans kicked on, they turned off, let that go, several times, let the car idle in, and everything worked good. So at this point, you can either, call it a fix and ship it, or you can just let it eat at you, like it does for me, because the fact is, fuses don't blow for a reason, particularly, high amperage fuse, 20 amp fuse. That really has given me, what the heck's going on here? So, like I said, I want to take it a step further and see if we can't figure out, what's happening, why the heck did that fuse blow, or at least get some clues, or, just do the best you can for your customer. Obviously if it's an intermittent short, that's tricky. You're going to have to get that wire to, rub through on that piece of metal at the exact time, and, find it and stuff, which, it's not impossible. But I always say, it's best to just kind of, verify 100% the best you can, and then ship it. So what we can do in this case is look at, the possible scenarios here, and the best way to do that is to look at the two individual circuits. So we'll follow this one down. I'll show you this is my process, and I actually do, when I'm doing these, I actually do, highlight just to kind of see what's going on. So we'll follow this wire down here and through, just follow each path. So this is going to go through the relay, assuming, all the relays work and everything, which if it didn't, that's not going to cause a short. So that comes down, and that goes to our main fan. And then the other source of power here comes down. It's going to go through our other main fan relay, up through the contact, and that's the other side of our fan motor. So on these, how these work is you have a common ground on the motor, one of these wires is low speed, and then when the second wire is energized, so both wires are energized at the same time, the fan is on high speed. So you know, that's just how these fans work. If you put power to this wire, it's low speed. If you put power to this wire, it's low speed. If you apply power to both wires, it's high speed. So basically what we have highlighted in pink is the power side of one cooling fan, the main cooling fan. And then we'll do the same thing on this. It's always good to have, you know, lots of different colors of highlighters, multiple circuits. So this one comes down through the relay, goes to the fan motor. The power continues on. It's going to come down. It's going to go through this relay and then back out. And then up to this motor. So same thing, you know, low speed, both of them energized is high speed. So essentially our circuit, you know, in order to blow this fuse, we can have a problem on any of the highlighted wiring that we have. Of course, you know, our power goes through our motor, you know, and back to ground, you know, and open in the ground isn't going to cause high current. You know, you got to think of, you know, what can cause high current and cause this to short. So you know, faulty fan motors could, but you know, we know that both the fan motors work, and you know, obviously any wiring problem. But I thought it was kind of odd that, you know, this fuse is blown and this fuse is blown, and they're two completely independent circuits. So what I chose to do next is, you know, personally I want to know, you know, when this thing leaves, I know the fans work, I want to know what the total amperage draw is on this circuit. You know, are these things running kind of borderline near, you know, blowing this fuse? The way I chose to do that is using a lab scope so we can see the motor. You know, we can see each commutator segment of the motor. I'm not really super concerned about opens in the motor because simply that, you know, won't blow a fuse. But, you know, looking at, you know, like high amperage spikes, or is this motor, you know, running at, you know, 19 amps, you know, and, you know, right on the verge of, you know, smoking that fuse, or, you know, what's the story? You know, kind of give us any clues, or, you know, does the circuit look fine? And, you know, we got to let it go, you know, completely unknowing, you know, why did that fuse blow? And I would take the time to say that this is a good example as to why, you know, I definitely promote testing the circuit as it's designed, you know, with load in place that's there from the factory. You know, as far as what is this circuit designed to do? Well, this circuit's designed to control this fan here on high and low speed, and control, you know, this fan on high and low speed. And we have the loads in place, so, you know, there's no need to substitute any kind of, you know, silly tool or anything to, you know, do any kind of open circuit testing, you know, anything like that. We can just test the circuit as it's designed with the fans in place and see what things look like. So what we'll do is we'll grab our lab scope, because that's the, like I said, the best way to have a look at this, you know, an actual picture. We're gonna go right in the fuse box. I grabbed a fuse loop, so we'll pull out the fuse. We'll put the fuse, you know, in place here. We'll stick that in the fuse box, and we'll just jam around this with our amp clamp. We'll have a look at this one fan, whichever circuit that one is. The one in the underhood fuse box. That is going to be our main fan, so that's going to be the fan here on the left. And then we'll do the same thing with the inside fuse box and have a look at that. We'll just look at them on, you know, one channel at a time to kind of save some confusion. We certainly could look at them both at the same time. The beauty of a Subaru is its ability to hook together the check connector under the dash. So there's two green halves of a connector on the dash. You hook them together, and that's going to go on. That's going to turn our relays on for us. That tells us a couple things. Tells us, you know, that our relays are functional. Tells us that ECM has the ability to control them, and, you know, eliminates a lot of the circuitry that we don't even have to look at. And then we don't have to take out our relay to do anything like, I don't know, squeeze it or, you know, anything obnoxious there. We don't have to, you know, jumper it or anything, because the car has the ability to control it. We don't even need a scan tool for any kind of bidirectional control, so that'll definitely help shortcut this process. So right here in the driver's side footwell, plug this data link connector here. If I get my dome stuffed up under here, there's a couple green connectors right up under the dash. I'll show you guys. So it's these little guys right here. We take those with the key off. We'll just clip them together if I can. Alright, so they're hooked together. And when you take and turn the key on, the engine light should be flashing, indicating that they're hooked. And it is. And you can hear it kicking on the relays out there. So what we'll do here is we got our, like I said, we got the Pico hooked up. We're going to take, oops, we definitely don't want to go there. We're going to go here, our probe. We're going to select our 60 amp current clamp in 20 amp mode. It's 20 amp circuit, so we shouldn't exceed that, hopefully. Put on a 20 amp setting. And we'll change our time basis here. We'll just go to like 20 milliseconds per division. Here's the hookup we have with the car. Like I say, just removed the fuse, stuck it in the fuse holder. We've got our amp clamp around it. Got it turned on. We'll zero it out. I had to throw a charger on it. The battery is getting pretty low on this car. Of course, we just got our Pico hanging up there. I'm going to take and turn the key on here. When those cooling fans kick on, we should get a good waveform here, a good idea what's happening. Alright, so we're going to have to change our scale here, actually. I'm going to switch the amp clamp over to 60 amp mode. And we're going to come up here and we're going to change it up here. Stop that, whoops. I'll let that plug in. So there's our low speed. And there's our high speed. Let me shut the key off. And this is why we took it the step further. So we can see, you know, if we check what the average of this would be, we'll just kind of, you know, shove it through the middle here. See where we're at. 20.67. So we are running essentially at 20 amps on that circuit. Average, I'm just guessing, you know, I mean, if our average is, you know, slightly, you know, let's say the line's there, you know, now we're about 19 amps. So it's obvious to see by looking at this motor, not only are we drawing, you know, amperage right on the verge of blowing that fuse, even though you can clearly hear the fan, you can see the fan working, but it's obvious looking at our waveform here that, you know, the motor is complete junk. I mean, we have amperage spikes here. What are they peaking out at? 42.59 amps. Of course, that's for, you know, a very short time basis, which, you know, we can see, you know, how long is that actually there? You know, it's milliseconds, 1.2 milliseconds, but it is peaking out, you know, at, you know, 42 amps. So that's pretty good. This is why we're going to take it a step further, and I think you guys can see what's going on here at this point. I went ahead and moved our amp clamp to the interior fuse box so we can look at our subfan motor. And it doesn't take long to look at this if you've looked at any DC motor or waveforms to know that this fan is junk. Grab that on the next one here. There we go. Let me shut the key off. So we can take and kind of look at the average. We'll just kind of throw that through the middle. So this one's running about 12 amps, 12.8 amps on high speed. But I mean, look at the opens and the dropouts in this thing and the missing, you know, commutator segments, you know, through here. This thing is absolute rubbish. Yeah, that's no really other way to explain it. The fan motor is definitely on its way out. So we can look at both of those diagrams, or both of those waveforms rather, and confidently say, you know, to our customer, you know, currently, you know, we look at the subfan and it's drawn, you know, what do we figure, about 12.8 amps. You know, it's not going to blow the fuse, but what if we add, you know, the right set of circumstances? What if we add heat? Or what if we add, you know, extreme cold weather like we've been having, you know, 9 degrees outside? You know, does that thing get a little bit more stiff? Is there, you know, is there some friction that's added that increases that amperage? But I guess that's really neither here nor there, because we looked at the waveform, the motor's shot, you know, the motor's absolutely just wore out. Just all there is to it, you know, 250,000 miles of cycling, it's eventually going to wear out. You know, the brushes are going to wear out, or whatever, you know, the case may be. And of course, you know, we could add a little bit of heat to this thing, you know, pulling that hot air off the radiator, and, you know, this amperage could go right up through the roof, given the correct circumstance, or, you know, hit a pothole just right, and, you know, something changes inside that motor, and, you know, lights out. So the fact is, this thing needs a couple motors, and we're going to get some. We're going to put a couple motors in it. We're going to redo the test, and then we're going to have another look at it. All right, so unfortunately on this car, the getting a couple new cooling fans was kind of out of the question for this customer. The new cooling fan motors through Subaru are extremely expensive, along the tune of almost $600 for the pair. And I believe that was just the motor assemblies. Aftermarket, I only found a main cooling fan, but we can see that our subcooling fan is failing anyway, so that kind of still left us in a dilemma. What I've elected to do is I grabbed a couple used ones in the salvage yard down here. Now these are, you know, a metal shroud on these fans. I did grab a set of plastic ones to see perhaps if they were the same bolt configuration on the radiator, and they're not. So we still are forced to use ones with a metal shroud, which, as you know, getting them from New York State on a 1997, well, you know what they look like. They're toast. But the motors on them appear to be good. So I've got a couple used fans over there. I'm going to pull these fans out. We're going to swap just the motors over. Reuse these metal housings, and then we're going to redo our tests. And you know, fingers crossed, everything should be good to go. And we'll get this guy back on the road for, you know, a whole lot less than, you know, the tune of, you know, like I say, $600 for a couple new ones. The shrouds on the ones from the salvage yard are just gone. The whole bottoms of them. I mean, these aren't the greatest, but they're a whole lot better than those ones. I'm always losing stuff. Two old motor assemblies. This one's actually, of course you guys can't. You want to feel how warm it is? This one's actually warm just from that short time. So this is the main fan. This one we tested first, so several minutes have passed and it's actually physically warm. So pretty neat. We'll fire the Pico back up. I think what we're going to do this time, I grabbed a second amp clamp and we're going to turn on both channels. We're just going to look at these at the same time. So we'll come down here. We'll just set them in the 20 amp mode this time. So I think that'll be best. So our blue one, our blue trace here, trace A, channel A, I still have that hooked inside the car. I never unhooked that. So it's going to be our sub fan. And this one here will be our main fan on the red trace. So let me go ahead and kick the key on. I got both amp clamps hooked up currently. Let's see. Taken down. So that is much, much nicer looking. And we'll kind of fine tune these here a little bit. So there we go. Let me shut the key off. I guess we got to keep in mind too that you know, these are used. I guess I can turn this battery charger off. That sounds terrible on the video. These are used fan motors. It is obvious that they are, you know, 1,000 times better than what we had in it, you know, prior to this. You know, we can see nice, you know, even humps. This was a capture on high speed. Our blue one we said is our sub fan. What would be our average current draw? Roughly about 9 amps. And then on our main fan here, where we at? That one there is about 10.57. That's a little bit bigger of a fan, so there's going to be a little more draw on there. Neither one of these are too awful bad looking, particularly for what we had to work with here. Seen a whole lot worse, I could say that. So there's our low speed. And on low speed, where are they drawn? 7.5 we'll say on the sub fan, and roughly 7.7. So that's pretty cool that we're actually able to see the fix. Let me go ahead and kick these on again. I'll get one more capture so I can save it for the library. Look at this. Oops. Grab my cursors here. Let me get it. There we go. Just as a side note, if you're using your Pico, do everybody a favor, including myself, is just save and share your waveforms. That way they get stored on the Pico library, and take good notes. We know what the heck we're looking at, and it just helps everybody because we get to build their library, and the only way we can do that is by saving it and sharing it, and it's easy enough to do. So we can just kind of peek back on here. So this is our initial one we did with the bad main, or this was a subcooling fan relay. You can take, I saved just a quick reference form off our sub relay that we saved, and you can kind of see there, good versus bad. Quite a difference. And it's just kind of a neat little thing we can do. We could poke back in. So we want to do, we want to look at the main relay. Down through some of my saved ones here. So we go to that's our bad one. It's good to save bad waveforms too. Just kind of look back, So here we'll open up the reference waveform I saved for that. And it's obvious to kind of take a look at these. See the difference. Bad versus good. So I guess that's that. Alright guys, well I guess I'll leave it at that, and I really don't know the purpose of the video once I got it started, but I guess it's just to help you guys out there, kind of motivate you to not get burned by these cars. Like I say, I sat here, this thing ran for 20 minutes the other day cycling these fans on and off, never blew the fuse, but the fact is, it didn't sit well with me to know the fact that it did blow the fuse, so I was going to make every effort possible to go in and see why. And it was obvious that, just quickly grabbing a scope, taking a quick current draw measurement on these cooling fans, we could quickly prove, hey, look, these fans are toast, and it's likely the cause of your blown fuse. Certainly, the one fan we're looking at that was drawing, running right at that borderline of 19 amps. Now, that one there, you certainly probably could have found that using, like a fuse buddy or something, and seen, this is pretty high current draw. But it's a fantastic tool having a scope, particularly the Pico. We could take a look at this and say, yeah, this fan's smoked. And thankfully, the used ones that we have are good, are a whole lot better than what we had, to say the very least. And I guess to stop any questions, yes, I checked them before I put them in, because I know a ton of people are going to ask, why I didn't bench test them. Well, obviously I did. I'm not going to go through all this work to put them in to find out that they're junk. So I did do that, so that'll stop that question. I'd kind of like to know your guys' methods and approach to, situations like this. Car comes in, you find a blown fuse, now what do? Do you ship it, or do you guys take the time to go through and try to duplicate the problem, running the car through different scenarios, heat, vibration, cold, whatever you can, wiggle test, whatever the case may be. Personally, I try to give the customers the best service that I can. And also to prevent comebacks. Nobody likes comebacks. You definitely don't want this thing coming back tomorrow with the same symptom. Guy sitting and got this thing warming up outside of his house, because it's cold outside. He goes out and the thing's puking antifreeze all over the ground. You definitely don't want that. It doesn't look good for you. Even if it's not your fault, or you didn't do something, but just do the best job you can. I guess that's what this video is all about. Do the best job you can, and try to do the best to help your customer or help yourself, whatever the case may be. And I think you guys can see how handy a scope is working on automobiles. Simple as that. So that's it. Thanks for watching. I think I rambled enough. Google+, Facebook, check us out there if you haven't done that. And subscribe to our channel if you haven't, if you want to stay up to date with the videos that we roll out multiple times throughout the week, and you never know what you're going to get, whether it's nuts and bolts or electrical diagnostics or check engine lights or changing tires. You never know what rolls through these doors. And just remember, viewers, if I can do it, you can do it. Thanks for watching.